Hello and welcome to our intermediate algebra class. Today we're going to be looking at interval notation and linear inequalities. Now it's pretty notational, and at first you're just going to have to get used to exactly what they're asking for when they ask for a particular type of notation. So let's get started on what they mean. We have something like x is, let's say, greater than 2. Now we've seen this before. We call this inequality notation. And if you were to graph it, typically we've been graphing it something like this. We draw a number line. We need a couple of points on either side. And we would say, okay, it does not include the 2 and it's everything greater than 2. So we would draw an open circle here, and then we would just shade in this line. This is called a line graph, and that's the way we used to do our line graphs. From now on, we'll be doing our line graphs with brackets. And a round bracket or roundy guy bracket is going to mean the same thing as what we used to call an open ball. So these two graphs are equivalent. They're both line graphs. So let's look at something that is pretty similar but a little bit different. Let's do one that includes the endpoints, something like this. So before, instead of an open ball, for this one we would just make a closed ball, close it up, say this includes the endpoints, bub, and then we would darken our line there to show it includes all those points on that number line. If we were to do it with brackets, instead of a roundy guy bracket, we're going to use a square guy bracket. So our bracket's going to look like that. And then we do exactly the same thing. We just shade it all in, but our bracket just looks a little bit different. These two right here are both equivalent, as are these two. One includes the endpoints, another one doesn't include the endpoints. Another type of notation that we're getting ready to do is called interval notation, and this is really what we're gearing up towards. Interval notation means you take whatever the endpoints are, so this one will be a 2, follow that exact same bracket, means it does not include the endpoint, and it goes all the way up to infinity, this arrow being positive infinity and this arrow side being negative infinity. And I would write it just like this. Now we don't include the infinity on that side because it's just something picky that mathematicians do. We say we can't include infinity because there's always something after infinity. Infinity plus 1. Alright, so I've listed these names here for you. One more type of notation that you'll encounter, although this one's not going to be used quite as frequently in the course, and it looks a lot like inequality notation really. But what we're doing is we're writing these brackets, and this says the set of all x, and then this straight line down means such that, and then we write x is greater than 2. See how it doesn't really look any different than inequality notation, but you do have this fancy curly Q bracket that says the set of all x such that x is greater than or equal to 2 for this particular one. There we have all 4 of the different types of notation that you're going to be using in this course, although this guy and this guy we're fading out. We're not going to use those anymore. You're going to be using this bracketed notation for your line graphs. And now that we've gone through how we're going to be writing our answers in this course and throughout the rest of your mathematics courses, let's work some problems with them. We're going to work some inequalities, and if you'll remember back from a while ago, if you multiply or divide both sides by an inequality by a negative number, you need to flip that inequality. If you'll remember, that's because it changes the direction of things. If you think about negative 2 and negative 100, even though 100 seems a lot bigger, it's actually a lot smaller because it's in the whole, or it's in the negative realm. So the seemingly larger numbers are actually smaller. So in the negative realm, it flips the direction of things. So let's look at a few problems. Let's look at 2x minus 3, and we'll just say is less than 5. And let's see how we would solve this problem. Now the first thing that we would do is we would say, okay, I need to get rid of that minus 3, so I'm going to add 3 to both sides. Ask yourself this question every single time. Did you multiply or divide both sides of an inequality by a negative number? Did I? Nope. I'm just going to add 3. Since I'm just adding 3, I can say, all right, I'm going to keep that inequality symbol. This goes away. Minus 3 and plus 3 is 0, so I'm left with 2x. 5 plus 3 is 8. Next thing I'm going to do is divide both sides by a 2. And when I divide by a 2, I say, did I multiply or divide both sides by a negative number? I did not. That's a positive 2. So x is then less than 4. This is my inequality notation, if you'll remember what we called it. This would be my line graph notation. I'm going to do it with brackets, so 4, I need one on either side. The computer will do that for you. It's going to take a little bit to get used to what the computer, doing that input on the computer, but it's really nice because it gives you the feedback instantaneously. If you have any trouble with it, be sure and email me. This is my line graph notation with a bracket because it does not include the endpoint, so I need a roundy guy bracket. And then to put it in interval notation would look like this. You just kind of follow straight down what this says. This is my negative infinity arrow. Just write it down, follow it straight down. So this would be my interval notation. So I didn't do anything where I flipped the inequality, so let's look at one where I would need to flip the inequality. We'll look at the same kind of thing, but we'll do it, I'll change it just a little bit so it be what I want it to be. I'll do the same thing to this one. I'm going to add 3 to both sides. Notice I did not multiply or divide both sides by a negative number, so I will keep that same inequality. I added 3. So I've got negative 2x, keep the same symbol, 8. Now I'm going to divide both sides by a negative 2. This time I did divide by a negative number, so I'm going to flip this inequality because it changes the direction of things. And this would then be a negative 4. This would be an x. Here's my line notation. Put my negative 4 here. This would be negative 3, negative 5. Need a roundy guy bracket. And darken it in. There's my line graph notation. And the interval notation is going to look like that. There, we've worked that problem. Alright, I'm going to work a couple of examples that, you might not, you look at these and you think, ugh, I don't want to deal with this. Number one, you don't want to deal with this first example because of the fractions. Nobody really likes fractions, but one thing that I'll tend to do is I'll get rid of those fractions. I want to get rid of those denominators, and I look to see what's a common denominator. Now this is just a trick. You don't have to do this. You could get a common denominator and work it straight, but I'm not going to do that. I like to get rid of them if I can. So I put parentheses around both sides, and then what I'm going to do is say I'm going to multiply both sides by a common denominator. And to me, when I look at 2, 10, and 5, I choose 10. You could choose 20, you could choose 30. It really doesn't matter. Just 10 is the smallest one, so it makes things easier. Next thing I'm going to do is I'm going to multiply. I'm going to distribute that to here and to here. When I do that, 10 times 1/2, that's going to be a 5, minus 10 times m over 10. The 10's cancel, leaving me with just an m. Cool little trick. Here I just have the 1, so 5 goes into 10 2 times, and I'm left with negative 2. Now this is so much sweeter to look at than the one with the fractions, so I'm good here. I'm going to subtract 5 from both sides. Did I multiply or divide both sides by a negative number? And up here I would have said to the same thing I actually did, but I knew that I didn't multiply by a negative number, so I didn't flip the inequality, just wrote it down. Zip here, minus m, and greater than or equal to, because all I did was subtract 5. I did not multiply or divide. And this was a minus 7. Now I'm going to get rid of this minus by dividing both sides by a negative 1. Did I multiply or divide both sides by a negative number? Why, yes, I did. So I'm going to flip that little guy. M, and negative 7 divided by 7, that is just a plain old 7. There is just my regular inequality notation. Line graph notation would look like this. And let's see, that'd be a squarey guy bracket because it includes the endpoint. Chunk, chunk, chunk. And I use this line graph notation to write my interval notation. You're the negative infinity guy, so I write negative infinity, comma, 7, squarey guy bracket. Alright, so that one is finished. Now, for this next guy, I wrote him down. They're going to take and wiggle these things all around, put a whole bunch of stuff in there. They're even going to have ones that, like this, that have fractions. You can still pull this little trick where you multiply everything by the common denominator. It makes the denominators go away. The first thing you have to do on this one is you're going to have to distribute. Now, I'm going to distribute this. So that would be 5x minus 10. Now this one's tricky, and I chose this one because of this minus sign, and that minus sign will trip you up if you are not careful. It's the minus 7 times the x, so that's going to be minus 7x. Then I'm going to do minus 7 times 1, and that's a minus 7. There's the place where I find students will miss it. So be very careful there. And all I'm doing is simplifying. I'm not multiplying or dividing both sides by a negative number, so I keep everything the same. Now I start collecting because I have, and I'm not going to move anything. I'm just going to work on this left side because I've got a minus 10 and a minus 7. Those can be combined. That's a minus 17. I got 5x minus 7x, and you guys can be combined into minus 2x. So there's what I have on the left-hand side. On the right-hand side, I still have my minus 4x plus 3. I like for my variables to be on the left side. It just makes things easier for me when I go to do these line graphs. So I like for my variables right here, like this m, I purposely put them on the left. You can do it the other way, but then you have to think backwards whenever you're trying to make a line graph. So first thing I'm going to do is add 4x to both sides. And when I do that, I've got 2x here minus 17. Did I multiply or divide both sides by a negative number? Why, I did not. So just copy that down. 3. Then I'm going to add 17 to both sides. Add 17. Did I multiply or divide both sides by a negative number? Nope. So I'm just going to copy down that inequality symbol. There's a 20. Divide both sides by 2. Beautiful. Did I multiply or divide both sides by a negative? Nope. So you are then just a 10. And I will then do my line graph. Put a 10 here, an 11, and a 9. And you're going to be a squarey guy bracket. Let's see, you're pointing this way. So this side, this arrow is going to be shaded. So there, and I need a squarey guy that looks like that. And it will be negative infinity all the way up to 10. Squarey guy, please. All right, so they're going to give you a bunch of problems that just kind of give you more practice with fractions, simplifying, and it's probably been a few weeks since you've done some math, so you'll have to shake the cobwebs loose. If you have any trouble, please send me an email, and I'll be glad to work with you. I'll help you with solutions and get started on them. Just let me know what you need. I'm here to help.